Hi everyone, this is our group study of scooters usage behavior at Kasetsart University. This is a part of probability and statistic for computer engineer. Why did we come up with this topic? Well, it is because wherever you go nowadays, this is a very hot and trending thing to go with. Scooters. And from that, we decided to choose this topic and wanted to know more deeply on how they decide. Is there any accident happen, or do they know enough rule to make it keep it safe? How many money they use it or spend on it? So all of these information are collected in 14 different questions through Google Form. And we collect information in total of 8 days. We use Google spreadsheet to do all of the calculations, and we expect 50 responses. However, we have one extra, so now we have 51 responses. We collect from many people all around the university from very first year until the senior years. Most of them are from engineer students, and a very interesting number. It's almost a 50% girls and boy we get an information form.
The next part is probability computation. There are two interesting relationships between pairs of data. The first pair of data that we are interested in is relationship between total university transportation cost, if not using a scooter per week, and total cost of on-campus travel per week. As you can see, we get three graphs. Two of them is histogram, the probability of x, the probability of y, and the last one is a 3D graph of probability between x and y. After we calculate the correlation coefficient between these two sample data, we found rho equals to 0.1444. It means that there are weak positive correlation between them. So if x increases, y will increase also. In the conditional probability part, we calculate the probability of y while x is greater or equal to 84. We get the probability of y equals to 0.7255.
The second pair of data that we are interested in is relationship between respondent rate their knowledge and understanding of scooter driving regulations on campus, and respondent access the extent to which they comply with the rule for riding scooter on campus. We get three graphs, the property of x, y, and a 3D graph of a property between them. After we calculated the correlation coefficient that equals to 0.3070, it means that there are positive correlation between them. In the conditional property part, we calculated the probability of y while x is greater or equal to 5 and get the probability of y equal to 0.8431.
For statistics, we start off with the descriptive one, which explain the overview like maximum, minimum, mean, median, mode, and everything. You can view more information in our Google Sheet. From here, this is just one of the example. The number of scooter usage time on weekdays, which is Monday to Friday. How many times does people use or go around with scooters per week? You can see that the minimum is 0 and the maximum is up to 12. As the graph represent here the histogram, the second one rises up higher than other people. This mean probably fall here. And that's right, our mean is at 3.27 while our median is at 2. However, the standard deviation is 3.23. What that means is our range is quite far.
Total university transportation costs if not using a scooter per week. As you see in this histogram, in the most data is on the left. Minimum of this data is 0, maximum is 380, mean is 69.8, median is 50, SD is 72.8.
The second one is goodnet of fittest, which we use chi-square, the table represent right here, to help us calculate. Now, we start off with having a hypothesis, and the alternative one, we use chi-square to help us prove, and then we conclude. This is how we go. So for example, we estimate the amount of time spent using a scooter each week outside the university follow the normal distribution. Following the normal distributions means that m is 2. So from that, we can calculate everything, which means degree of freedom and everything. I skip it here, but you can view it in Google Docs. documentary. In here, chi-square said that our test statistic is 34.372. Significant level we choose at 0.01, and the rejection region is if it's more than 24.322, then reject. And as you can see, our test statistic is more than that. So we can conclude that it rejects the null hypothesis. This means we have to answer the alternative one, which is the number of scooter usage times on weekdays, Monday to Friday, does not follow normal distributions.
Goodness office state for total university transportation cost if not using a scooter per week. We set up two hypotheses. The null hypothesis represents that distribution is normal. The alternative hypothesis represents that the distribution is not normal. To test this hypothesis, we calculated the test statistic, which turned out to be 3.38. We set a significance level at 0.01, and then we will got the degree of freedom, and that will define our rejection region, which were found to be 9.21 and 13.23. And based on the result, we conclude that the test statistics less than 9.21, so it's failed to reject the null hypothesis.
A very last one for our statistics hypothesis test. These hypothesis tests is a large sample size because we collect up to 51 samples, so all of this is large. And from here, we start with having a hypothesis again, an alternative one, then we test it with the statistics, and we use this formula right here that I put it in the slides. So this is how it goes. A number of scooter usage time on weekdays, Monday to Friday, is usually 5 minutes. That's my assumption on my hypothesis one. My alternative one said that no, it is more than 5 minutes. When I say more than, this means that our rejection region must be an upper tail test. But before we go to that, we need to calculate. We know that our X bar is 3.27, and the rest of the number is as shown. As you can see, our test statistic is negative 3.82. We choose an alpha of one number, and that led you to rejection regions, which we got C is more than and equal to 2.326, which what this means is that it is lesser than, so it is not rejected. The number of scooters usage time on weekdays, Monday to Friday, is indeed 5 minutes, so the hypothesis is right.
The hypothesis test for total university transportation cost if not using a scooter per week. We aimed to determine whether the average usage money is 50 baht. The null hypothesis state that the average usage money is 50 baht, while the alternative hypothesis state that it is not 50 baht. For this test, we calculated the test statistic, which result in 1.94. We use two-tailed test to find a rejection regions. And based on our test result, we conclude that it failed to reject the null hypothesis. So the university transportation cost, if not using a scooter per week, is 50 baht. Conclusion: the relatively low number of accidents involving scooter on campus indicated a reasonable level of safety. Although ongoing effort to ensure safety and compliance with scooter usage regulation may be considered. Our study suggests that scooter may not be as popular as expected because many people don't cover significant distance with them. Also, people use scooter more on weekday than weekend.
The correlation coefficient of the relationship between total university transportation cost, if not using a scooter per week, and total cost of on-campus travel per week, shows weak positive relationship, which means if total university transportation cost, if not using a scooter per week, increase, the total cost of on-campus travel per week will slightly increase too.